Alright, hey guys. So this is Learning Target 3.3 notes. Learning Target 3.3 says I can prove that two lines are parallel using angle relationships. And the three specific parts of it are: I can state the postulate that proves two lines are parallel, I can find the values of a variable so that two lines are parallel, and I can prove that two lines are parallel in application problems. So before we get to the definitions that we're going to use in this, this isn't really going to be new stuff, except like it's not going to be new information. You're going to still use alternate interior angles and all the stuff that we're going over, but the difference is, instead of going from knowing that two lines are parallel to then finding the measurements, we're going backwards. So we're going from knowing measurements to proving that two lines are parallel. So when we go backwards like this, we call it the converse of what you originally learned. So all of these definitions that we're going over in these notes are called, they're the converse of the original one that you used. So for example, the first one says corresponding angles converse postulate. And this one is if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So this in kind of picture and notation form is if I have two lines and they're cut by a transversal, and I know that this angle and this angle, which are corresponding angles, if those are congruent, then we can say that the lines are parallel. So let's label this angle 1 and this angle 2, and label this J and K. So what we would say is that if the measure of angle 1 is congruent to the measure of angle 2, then J is parallel to K. So basically we took that if-then statement that we had up there in words and we put it in kind of a notation form. And we probably won't do that for each of these, but that's kind of the formal one for us. Alright, so the next one is alternate interior angles converse. If two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So in picture form, we won't do the notation, we'll just do pictures. So alternate interior angles, if those are congruent, then we can show that that is parallel to that. Alright, next one's consecutive interior angles converse. If two lines are cut by a transversal so that the consecutive interior angles are, and this is the one that's different, consecutive interior angles are supplementary, sorry, that looks awful, then the lines are parallel. Here, I'll write this underneath so you guys can see. So supplementary. Okay. And our picture of two lines cut by transversal, and we have consecutive interior angles, so those two. And I'm going to put two little different markings so we remember that those two aren't congruent to each other, but that they are supplementary. They add to 180. So we could say that, well, if we do 1 and 2, that the measure of angle 1 plus the measure of angle 2 equals 180. Then we can say that these two lines are parallel. Alright, last one, alternate exterior angles. This one I just gave to you because I think you kind of got the pattern right now. If the two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. And your picture, two lines cut by transversal, and we have our alternate exterior angles out there. Alright, on to some examples. So, given the following information, determine when lines, if any, are parallel. State the postulate or theorem that justifies your answer. So there's kind of two parts. You're going to look at the angles. You're going to determine what two lines are parallel, if those are congruent or whatever, and then we need to state the reason why. So if we look at angle 3 and angle 7, so got my little marker here. I've got angle 3, and why is that not working? Oh, that's going to cover it up. Angle 3 and angle 7. So if those two are congruent, what can we justify? So those two angles are what kind of angles? Hopefully somebody said alternate interior. So they're alternate interior angles. And so the transversal in this case is line L. And so the two lines that it's cutting through, A and B, are what 3 and 7, by being congruent, prove that they're parallel. So we say that A is parallel to B, and it's because of alternate interior angles. Alright, next one. Part B. So angle 2 is congruent to angle 16. So 2... Why is this not working? Angle 2, angle 16. Okay, so if those two are congruent, then we know that they are alternate exterior angles, and the transversal in this case is A, and the two lines that it's cutting through are L and M, so we can say that L is parallel to M because of alternate exterior angles. Whoa, that E looks weird. Let me fix that. Okay. C, angle 1 and 11. So here's 1, here's 11. So right off the bat you should notice that they are not any of our things. They're not corresponding, they're not alternate interior, they're not alternate exterior. And some of you might want to say that they are corresponding. However, and even though they're in the same spot, they're technically not along a transversal. They're not along the same line. So actually this one is none, that we cannot determine anything as parallel. So from this we cannot say that any lines are parallel. So we put no lines parallel. Alright, last one. It says that measure of angle 5 plus the measure of angle 12 is equal to 180. So we look at 5, and we look at 12, and I say, okay, well it says it's 180, so that needs to be consecutive interior angles, and they are, and the two lines that would be parallel for this one would be L and M, and we'd say because of consecutive interior angles. And we'll just abbreviate that. Alright. Example B. Find X so that L is parallel to M. So this process is really just the same as you have done before. You're basically just going to find X is really what it's asking you to do. So we have 6X plus 4 is equal to, oh sorry, well it is equal to, but 8X minus 8. And the reason why I said equal to is because they're alternate interior angles. And alternate interior angles are congruent. So we can set things equal to each other. So we do 6X plus 4 equals 8X minus 8. So I solve for X. So I would, personally I would subtract the 6X from each side first. I would get 4 equals 2X minus 8. And then you're adding 8. And then we get 12 equals 2x. And the last step is that you divide by 2. So x is 6. So what we've done is we found that if x is 6, then we can say that L is parallel to M. Alright, last example. Example C. If two boats sail at a 45-degree angle to the wind as shown, and the wind is constant, meaning things aren't going to change, will their paths ever cross? And explain. So we've got our little sailboats and they're traveling along. So they stay at that 45-degree angle forever, according to this. Will they ever cross paths? And we can say, well, no, they won't, because what do those two angles form? Hopefully you guys said that they, I shouldn't say said form, but they are corresponding angles. So because they're corresponding angles, we could say that will their paths ever cross? No. They will not cross. Because the two angles are corresponding. Alright, so that is it. And Eric has your assignment. And oh, if you don't finish your assignment today, don't worry, we will finish it tomorrow. But I think you guys can hopefully get a good start depending on how long you took on other stuff.